Hi, I'm Wei-Lun. I'm going to present our work in MICCAI 2023, Skin Lesion Correspondence Localization in Total Body Photography. It's a joint work between me, Davuta Shayod, Jun Khan, Amir Ganshbek, Michael Kastan, and Meron Ahmed. TBP is beneficial to the early detection of melanoma, the most deadly skin cancer. It helps with longitudinal tracking of skin lesion, which is finding lesion correspondence and detecting the change of pigmented lesions. Researchers have built TBP systems and developed algorithms to find lesion correspondence. However, these methods are only applicable to well-controlled environments. In particular, these methods assume similar body pose and camera parameters across scans. The concept of using template mesh for finding lesion correspondence has been proposed. However, it's challenging to deform a template mesh to fit varying body shapes. Additionally, geodesically close locations may be distant from each other in the texture map. In the work from Zhao and others, they did not use texture in the matching step. In response, we propose a novel framework to find lesion correspondence based on three key observations. First, body landmarks and geodesic distance can be used to establish an initial coarse correspondence in 3D meshes. Second, texture information can be used to further refine the location of the correspondence. Lastly, similar to how a human annotator will label lesion correspondence, once confident lesion correspondences are found, they can be used as new landmarks to help with finding the correspondence for other lesions of interest. The input to our method are source and target mesh, their corresponding landmarks, and lesion of interest in the source. We would like to find their correspondence in the target. First, we define geometric feature descriptors for each vertex based on the geodesic distance from the vertex to the landmarks. We then create an initial dense correspondence based on the similarity of the geometric descriptors measured by normalized cross-correlation. While geometric feature descriptors of corresponding vertices on the source and target mesh are identical when the landmarks are in perfect correspondence and when the source and target mesh differ by an asymmetry, neither of these assumptions holds in real-world data. Therefore, for the initial correspondence, we associate a local region with the vertices that are geodesically close to the correspondence and with the vertices that have high similarity in their geometric descriptors. Then, we refine the correspondence based on texture descriptors within the local region. Specifically, we select the echo descriptor defined on the texture signal with 3 radii. The correspondence is derived by the weighted sum of the similarity of texture descriptors in 3 radii. While each source lesion of interest has a corresponding position on the target mesh, not all correspondences are localized with high confidence. We define the confidence by texture similarity, agreement between geometric and textural correspondences, and unique existence of a similar lesion within the region. In each iteration, the high confidence correspondence will be added as new landmarks. We iteratively relax the criteria and look for lesion correspondence. Finally, for the remaining low confidence lesion of interest, we find their correspondence by the weighted sum of the similarity between their geometric descriptors and texture descriptors. We evaluate our method in a public dataset, Skin 3D, and a private image-rich TBP dataset. Our success rate at the 10 mm criteria is comparable to the only reported method on the public dataset. We also demonstrate the effectiveness of the iterative algorithm. The iterative method consistently performs better in success rate under the 20 mm criteria. In conclusion, we propose a novel method to effectively find lesion correspondence across TBP scans through 3D textured mesh by leveraging geometric and texture information. The method is robust to changes in body pose and camera viewing directions. We believe the proposed method will serve as a valuable step for the longitudinal tracking of skin lesions.